Hi everyone, welcome back. Today we're doing check if two string arrays are equivalent. For this question we're given two arrays of strings, word1 and word2. Okay, oops, that's terrible. Let me undo this. Okay, so we have to return true if the two arrays represent the same string and false otherwise. So for example, in the first test case, word1, in this case, it contains a b as the first string and c as the second string, and this is word1. For the second array, word2, we have a in the first position and b, c in the second position. And we can see that if we are able to combine all of the strings together, both word1 and word2 will give us ABC, and that is why the output is true. In the second example over here, let's remove the old workings. In this case, for example 2, word1 contains A in the first position and CB in the second position. This is word1. For word2, we get AB and C as W2. So if we combine all the strings together in word1, we get ACB, and word2 is ABC. In this case, these two are not equivalent to each other, so we return false. And that's pretty much it. For this approach, one way to solve this is just to iterate through each of these words and add it into and concatenate it into a final string. And at the end, we will compare whether if these two strings are equal to each other. So that's pretty much it. There are some little quirks depending on which language you use. If you use C++, strings are mutable, so it is safe for you to append strings to strings very efficiently. But if you're using a language such as Java and Python, unfortunately the strings in this case are immutable. So what this means is when you are trying to add C to a string like this, what you're really doing is you are copying each of these characters in the original string before adding C to the back. So as you can imagine, it can be very expensive. So for example, if you have A and you add B to it, then you would need one operation to put A there. Let's say you add B to this, one operation to just copy the original A, and another operation to put B here. Now if you add a third character, C in this case, just to be sure, the first operation already takes two operations. If you add C to this, then you're going to take two operations just to copy A, B, that's two already, and one final operation to add another variable there. If you add another D to this, then you will need another three operations to put A, B, C into your copy and put D at the back. And that's going to be four operations. And as you can imagine, you can see that the computations follow something like a square, where as you increase the number of characters represented by n here, your number of computations will scale quadratically. To be specific, n squared divided by 2. But if you remove the coefficients, this is really n squared if you are not careful. So if you are trying to do this in Python and Java, it's best for you to append the characters that you want to join into a single array before you do one final copy across all these arrays. So that's pretty much it. And with that, let's move on to the implementation in multiple languages. Now that we have the algorithm down, let's do this in C++. Fortunately, in C++, strings are mutable, so we do not have to do the same dance of using string buffers that pretty much take every single string and copy it into a character array and recreating a string. We don't have to do that in C++ in this case, fortunately. So to do this, the approach is very straightforward. We will define a string object from the standard library, one for word1 and one for word2. We will proceed to iterate through every string objects in each vector and append them to their respective strings. And afterwards, we would just use the equality operator to compare them. So let's first define word1 string, define this as an empty string, and we will do the same for word2 string over here. Now let's iterate through every single string object in word 1. So for string word in word 1, let's do word1 string plus equal word. And we will do the same for all string objects in word 2 as well. Now the answer is just word1 string equals to word2 string. Yep, that's pretty much it. Let's run this against the test cases. This passes, and let's submit this. And there we go. We managed to get this right. So now let's take a look at how this works using a sample test case over here. So this over here, we have word1 equal to a vector of size 2, and the same for word2 as well. We will initialize word1 string to be an empty string, and same for word2 string over here. So now we will start to iterate through every single word in word1. The first word is AB, and we'll append this to word1 string. Now word1 string will consist of AB. We move on to the second and final element, which is C, and now we get ABC. Let's move on to the same approach for word2. First string is A. We'll put A into word2 string, and finally BC. We put BC into word2 string, and now we compare ABC equals to ABC, giving us true. Now let's talk about the time complexity, the worst case time complexity. Now if we let n be the number of characters in word1, which is pretty much the vector of strings, and m to be the number of characters in word2. In this case, the time complexity in this case would be, we'll be going through all strings in word1, and let's say that across all words in word1, they have up to n characters. So in this case, this will just be on. Same for word2 in this case, and that's pretty much it. It's just on plus om. So time complexity is on plus m. Now let's talk about the space complexity. In this case, we are appending every single n characters across all words in the vector of strings into this word1 string. So this will have up to on space, and in this case it's going to be om. And just for information, every single character would have 1 byte in this case. So you can roughly see that this is going to be n bytes and this is going to be m bytes. There's some additional memory used for referencing and stuff inside this string object, but that's more or less there. And in this case, we use constant memory for these reusable string variables. So this is constant memory, and yep, this is also constant memory as well. And that's pretty much it for this demonstration. If you found this useful, please give us a like and subscribe, and we'll see you in the next video.